In this video, we're going to have a look at how to differentiate the inverse trig function, the inverse of cosh of x. So I put two little telltale signs here that we're going to use later on in the question, because I never advise my students to remember each and every step, but rather two steps that then end up leading to the answer itself. So to start with, the function that we're actually differentiating, let's let that equal a letter, let's say y, just to make things simple. So let y equals the inverse cosh of x. Before we differentiate, what we want to do is apply cosh to both sides of this equation, because we get cosh of y, and then the cosh cancels out with the inverse cosh, leaving you with just x. Once you've reached that stage, you then want to apply step number 1 that I've written out here. You want to differentiate both sides with respect to x. Now you have to be careful here, because on the left hand side what we have is not with respect to x, it's a y term. Now when you differentiate cosh, that leads to shine. But because we're differentiating with respect to x, you sort of treat this as implicit differentiation. So it becomes shine y and then dy dx. Now when you apply this to the right hand side now, if you differentiate that with respect to x, well, that just differentiates to 1, right? And once you've reached this stage, what you want to do is you want to divide both sides by shine of y. When you do that, you get dy by dx is equal to 1 over shine y. However, what we see is in our answer, everything's in terms of x. So how do we go from shine y to x? Well, that's where step number 2 comes in. Because we started off by saying x is equal to cosh of y, if we use this expression here, cosh squared y can be replaced with x squared, because that is the case with our substitution. So we can say x squared minus shine squared y is equal to 1 when we substitute into this expression. Let's now make shine squared the subject, or just shine of y the subject of this expression, because once we do that and it's in terms of x, we can replace shine of y with that new expression. So we start by adding shine squared y to both sides. So the right hand side becomes 1 plus shine squared y. After you've done that, you then take away 1 from both sides, so we get x squared minus 1 is all equal to shine squared y. After you've done that, you then square root both sides. So we get the square root of x squared minus 1 is equal to shine y. Now we can replace shine of y with the square root of x squared minus 1, and our final answer becomes 1 over the square root of x squared minus 1. So apart from the step where we introduced this as y and applied cosh at the beginning to both sides, you could put that as an extra step if you'd like. But these two steps will always lead to the answer in this question. Now, what I'd advise is, if this method helps you, do make a note of this. I like to tell my students to make condensed notes, but if it doesn't, maybe make your own little method up, because what I found when I was an A-level student, when I made my own method, other people couldn't understand it, but I understood it really well, and it helped me remember things long term. Be sure to leave a like if the video helped, and subscribe. I'd appreciate it a lot. Thanks for watching your video. I hope it helped. If you have any tutoring inquiries for A-level further maths, be sure to hit my website up at www.excelineducation.co.uk.